So my plan here was to just go through some of the background, in case you don't know, or what value Stratux will give you. And just kind of make this informal. I see a lot of people with parts here, so at the end we'll probably work on building, or if you need help building, we can work on it. After that, we'll work on the background of how it works and what you can use it with, what apps you can use it with. Show you a demo of the web interface that we have, and then we're going to build. So the biggest issue to work with ADSB receivers is figuring out which one you need, I guess. There's two systems. There's the UAT, and then there's the 1090 extended splitter. We have two functions, ADSB in, ADSB out. A lot of people are talking now about out, the 2020 mandate and all that. Both functions work on both systems, so you can have 4 different permutations there. ADSB out, in case anybody doesn't know, it's part of the FAA's next-gen efforts. We have the 2020 mandate. It's similar to Mode C, Mode S, has a lot more data. It uses GPS, and instead of being interrogated by a radar, and the radar figuring out where you're at, your aircraft, your transponder will be telling ATC ground towers where you are at. And important here, Stratux doesn't do out. It's just a receiver. So ADSB in, we're going to be receiving traffic from other out transmitters, weather and traffic from the ground towers. There's the retransmit feature, which we'll get into, of the UAT ground towers. And this is what Stratux does, receives. Okay, so we have 2 different frequencies. We have the 1090 ES, which is original idea for ADSB. And then UAT was designed to solve the bandwidth issue. So the extended splitter still is required for flight above 18,000 feet. I assume it doesn't apply to most of us here, but it's important to know this because when you build a Stratux, you can decide if you want a 1090 receiver, you just want a UAT receiver, you can have both. We have some users outside of the U.S. because 1090 is a standard, international standard. So we have people in Canada and in Europe that are using the 1090 only receivers. So most users are currently, in the U.S., are only transfer carrier aircraft. So we only get traffic on this frequency. UAT is where we're going to be getting all the weather and all of the traffic rebroadcast data from, and UAT is most used for general aviation flying. So this is just a rough diagram. An aircraft that's equipped with ADSB out receives its position via satellite, GPS, lost GPS. And it's going to be sending its position to other aircraft, and that's what our 1090 receivers and UAT receivers are picking up. And it sends it also to the ground towers, which eventually ATC will be using to figure out, to use this information. Okay, so this is more applicable to us, Stratux. The ground towers are sending traffic information. So even for a Mode C aircraft, a non-ADSB out, it's being tracked as a target in the ADSB system, and it will be sent via the ground towers and UAT frequency to your aircraft, and Stratux can pick that up and show you what other people are seeing. And this is just showing you a direct in, just the inflow here. Directly you can pick up from 1090 in this case with a large aircraft, and then picking it up from the tower also. And you're doing then, say, an iPad. Okay, so this is the hockey puck. A lot of people will talk, you'll hear about picking up traffic from another aircraft's hockey puck. So if an aircraft like this one has ADS-B out, the ground towers are calculating a 30 nautical mile diameter around it and 3,500 feet above and below. And they're sending traffic targets that the ground tower is tracking that are within that hockey puck. There's been a lot of talk about this going away, and the ground tower is actually retransmitting all traffic. Something that might happen sometime in the future, but for now this is how it works. So if you don't have ADS-B out in your aircraft, I get the question a lot, will I get traffic? You're not guaranteed to get traffic. If you're outside here, you don't have ADS-B out, you will just be seeing traffic that's close to this guy. And if there's another one that's outside of it, then you won't see him on your UAT reception. So oftentimes when you're close enough to an ADS-B out aircraft, if you're around here, you'll get traffic that's good enough. This is coverage. The FAA has rolled out a number of ground towers. Almost anywhere in the continental U.S. you can get coverage at a reasonable altitude. That's useful enough. So now this is background on Stratux. Stratux is a software package. So I started working on this just as a way of using commercial off-the-shelf hardware and turning it into a receiver. And so that's what Stratux is right now. It kind of encompasses the whole, I see a lot of people here with the custom cases, the hardware design. We're working on the different GPSs and such, but this is what Stratux is mostly. It's the software. So it's designed to run on Linux. It's a free operating system, open source operating system. It's designed to run on specific consumer-grade hardware. So we have the Raspberry Pi. It's a very small computer. The DVB-Ts, the radio receivers, originally meant for receiving digital TV. It was discovered just only, I think, 4 or 5 years ago that by a Linux kernel developer that these could be used to receive radio signals that are very useful for other things other than radio reception, for TV reception. And optional, the basic Stratux is just a Raspberry Pi, one radio receiver, and power. It's really that simple. That's all you need to get traffic from the UAT, from the ground towers, and then weather. So you just need those three things really. Optional is GPS modules. A lot of people are using this. We have this $15 GPS. It gets WAS and receives WAS and gets really accurate GPS positions. We have AHAR sensors. We're still working on AHARs. And the whole purpose is just to relay traffic, weather, flight data to an EFB. ForeFlight, FlyQ, WingX are there. The original intention was for it to work with ForeFlight because that's what I was using. But now we've gained official support with almost all of the major non-ForeFlight EFBs. It still works with ForeFlight, but it's pretty well supported. So this is the reason it was made to work with ForeFlight other than the Stratus hardware. Low cost, reliable. A lot of people are running them. It's the same hardware that that FlightAware receivers are based on. Right now, FlightAware sends out these Raspberry Pis with the DVB tuners, or the tuners, and people are running them 24 hours a day, and that's what their ADS-B reception is based on, just these Raspberry Pis with radio tuners. Open source, so it's kind of a benefit. It's development on Stratux has been very fast in the past 7-8 months now. gained exposure, and just for being open source, free, a lot of people have come and participated, and it's made things happen a lot faster than it would have otherwise. This is the original EAA article. Said they're going to publish it this April. I think it's going to be in their Sport Aviation magazine. But this gained gave Stratux a lot of attention. Just last month, Aviation Consumers on the front page, they did a review. A lot of people think it's critical, but I think it was a fair review. The best part of that was that showed that they compared the Stratux with the Aperio Stratus, and they actually found that the Stratux is picking up more traffic. Here's some examples. RV7, I've got a Beach Baron, Gulf. This is my favorite, the Gulfstream. Behind the heads-up display, got these two antennas. That's another Beach Baron. Yeah. So what it receives, you'll get METARs, TAFs, radar, winds aloft, PIREPs, TFRs, AirMet, segments, and traffic. Most of all of the weather products that you typically use will be updated within 5 to 10, even 5 and 15 minutes. They'll usually be up to date as long as you're receiving over that time period. So I just have some examples here. This is in ForeFlight. It works in a number of other apps, like I mentioned, but the way you can tell in ForeFlight is just seeing this ADS-B specification. It's the same thing that that you'll hear on the radio. The same thing that you'll get over internet when you download the METARs. And radar. So you'll see it looks a little blocky. It's just typical of the way of how it's sent out. Radar that's sent from the ground towers is not very high resolution. So if you're using XM, radar from satellite weather, so precipitation will make it update faster. But if you expect 15 minutes, it being 15 minutes old, it's fairly good. And they're time stamped as well. If you look on ForeFlight, I think right here, there's a specification for when the sample was taken. You can see it. This is what the national radar looks like. It picked up here. Looks okay, but it's because I'm zoomed out a lot. If you zoom in, it's blocky, but it's still usable. This is what a PIREP looks like. You get all of these as they come in. I feel like it's pretty useful. You'll see in ForeFlight ADS-B when you get it. Any other EFB, it's not guaranteed that they actually have the weather implementation. So EFB in other apps, if they've actually implemented these things, I found that ForeFlight is actually one of the better ones in terms of support for weather, because they have the Stratux product, and they've done a lot of work in making sure it's supported well. So you find this is in ForeFlight, but some other apps don't have it. ADS-B specification, AirMets and segments update over the air also may or may not be useful. This is an example of traffic. This is how ForeFlight shows it, and I think many other EFBs show it. It's relative altitude. So this, I'm here, and this guy is 2,700 feet above me. This guy over here is 1,800 feet below. And these are the towers I'm picking up. You'll see also in busy terminal areas, here's Detroit, you'll see ground traffic. The towers will retransmit, and you'll see a big block of a bunch of aircraft that are centered in a large airport. But that's part of the benefit of ADS-B is for a ground controller, it's useful. For you, it's probably not. Okay, so this is traffic also. I was picking this guy up here. It's an American Airlines flight. You'll get a lot of this when you install a second tuner for 1090. This guy's 30,000 feet above me. So it depends if you feel it's useful or not installing a second tuner. Yeah, it's probably another $25, $30 in extra parts. Maybe if you're flying in a busy terminal area, these guys have 1090. See, this Delta Airlines guy is it's only 1,200 feet above me. It's far away, but may or may not be useful depending on where you fly. In this, okay, comparison. This is what the Stratus 2S has, the latest Apereo commercial product. They have the 978, which is the traffic weather frequency, the 1090, which will show you most of the airliners. WASP GPS, it's actually the same. It's called, we've discovered that we're using a guy that's the contributor to the project actually used a Stratus. He tore down his Stratus and figured out what components were in it, and they're using as U-Blox GPS, which we've been using all along. So the biggest issue is that they're so expensive that nobody wanted to disassemble it. So we finally figured out what's inside. So it has AHRS. Some people use it. Wi-Fi connection. These are all over. The Stratux and the Stratus both operate over Wi-Fi, not Bluetooth. So you're not going to be able to do anything like you would with Garmin Pilot. That expects a Bluetooth connection and also a different protocol from Garmin products. Battery life, 8 hours, for flight only. There's some other apps that support the Stratus now, but it's not official support, so it's $900. Stratux, so this is your basic Stratux build. It just has the UAT, and so it gets you traffic and weather, Wi-Fi connection also, battery life 8 to 10 hours with the recommended Mashi battery pack. It's like $15. It can be hardwired also to ship power. Works with ForeFlight, not officially, but works very well. That's the one I'm using. FlyQ, WingX, AvNav, iFly, a few other ones. There's a big list, but the rest of them are all supported officially. And that's $105 in parts, all in. And this is if you want to add a second tuner. You can, or add other modules to it, like a GPS. You'll have, typically people will add a second tuner. It's another $20, $25. Sometimes you'll have to upgrade your cabling and such so that it can handle the extra power load. You can also add a WASP GPS, which is about $15. AHRS sensors, it's all on this board with a WASP GPS. And that comes for $30, $40. Also has a Wi-Fi connection, lower battery life because it has the second radio tuner. These are the ones that really use a lot of power. It's still fairly acceptable, I think. Okay, so what's needed for a Stratux build? It's a Raspberry Pi 2, the radio tuner, and a battery or other source of power. The hardest part about this really is writing the SD card, the software onto it. You'll need a computer to do that, or now there's a number of vendors are actually shipping the Raspberry Pi kit with the SD card pre-programmed. So it's really couldn't be easier if you get it from one of those vendors. You need the Stratux software also. This is what it looks like. It's Raspberry Pi 2, radio tuner, battery, and that's it. So there you go. Yeah, that's your computer with the software and all that. It comes with a lot of extras, cabling and all that, but you don't use those. Also, you'll notice it comes with a remote control for this tuner. It's because it was originally meant for viewing television, but we're using it for other purposes. throw it out. Yep. And so this was my first build. I just Velcroed it all together, and so this is the case actually that comes with it. It comes with this clear plastic case, and that's been the biggest modification or addition that a lot of people are doing. You can get 3D printed cases. You see a number of them here. You can really put it inside of anything. It doesn't matter. Yeah. Yeah, a broken one. Yeah. Yeah. Okay.
This is why I spent $2
Yeah.
for a pencil case and custom wood
Duct tape.
and it works just as well for $50.
Yep. It does.
Without paint.
Yeah, so you can send them out to have them 3D printed. The designs are all online. You can pick out one that you like and have it whatever color that you want. Or if you have a 3D printer, you can print it. That's it. Yeah. Most people say it takes 10 to 15 minutes. That's really, and that includes usually loading the software. Hardest part is loading software. Now the supplier of the preloaded SD cards, it's been out of stock for a little bit, but that's coming in. So now I'm just going to go over a few things that you can do to customize your build. Things that might be useful depending on your application, and then we'll probably work on building. So ship power works fine. One of these, just make sure you get one that's rated well and is able to put out at least 1.5 amps. Extra battery. Bigger batteries, they're plentiful on Amazon. Y cable, this is very important. It's probably the biggest issue that we have with people that are building dual tuner Stratuxes. Reason being is that they pull a lot more power and you need a good quality cable. So you see a lot of USB cables. We've torn down a few of them and usually have 24 gauge wire inside of them. Cases, so all of this is online, it's free. People that have built their own Stratux and built their own case for it, I think there's online, on the main website, it's linked. There's about 18 different designs that you can have sent out in different materials. Most of them are built in ABS plastic. This one's Lexan. More cases. This is a hard drive case. I think it was less than $2 for the pencil case. This is a modem, an old modem. It's turned into a Stratux. This is what's inside. He did a pretty nice job. He has the battery, 2 tuners. This is the RY835AI. It has AHRS and GPS. And he cabled it to a BNC cable, which he hooked up to his belly antenna. That was pretty nice. And power button too. This is one of the common antennas. If you want to upgrade or change the form factor of your build, really the antennas that come with the tuner just work really well. These ones are just mostly for looks, and it's maybe a little bit more stable depending on how you're building it. It's tuned for 916 megahertz. You can use it for both bands. If you're building a dual tuner Stratux, you can just use 2 of those, or you can use a splitter and just use 1. This is what I'm having installed on my plane. Looks like a transponder antenna. They call it ADS-B antenna. It's $15. You can get one of these. It's meant for 978. Did you want to? It's not compatible. They released it, I think, a week and a half or 2 weeks ago, and I just got my test unit yesterday. I've tested it, and a few people have tested it as well, but it's not working. They have yet to dial in the software for the Wi-Fi. That's something that Raspberry Pi is still working on too. So it's a good option when we get to when the software catches up to the hardware. I think so. We'll have to test it. It looks like it's going to be. Yeah. So. Yeah, we've experimented also with the Raspberry Pi Zero, which is a $5 version. It works. We got it working on that as well. The problem with the Pi Zero is that they're just so cheap and you can't really find them anywhere yet. They also came out with that maybe 2 months ago, but it could be if they solve the supply issues. But for now, the Pi 2 serves all of our needs and works great. Other than that, it would just be mostly cost savings. Temperature is not really an issue. It might be depending on your case. I've had a few people build their cases with PLA plastic. It melts in the sun. But you'll notice that the tuners do get hot. Yep, and they're meant to run hot. People run these also, like the Pileware project, or FlightWare. They're running them 24 hours a day in all kinds of conditions. Nets are chosen by them. It works fine. Yep. Yes. Some cases have fans. I don't really think it's a concern. Okay, so this is so there was a Kickstarter project that started to build these cases and make what the maker is calling a quick build kit. So it all comes together. It comes with this exact case and with all the parts together, pre-programmed, and with support from the project maintainer. And he's selling them for $200 for the single band and $250 for the dual band. He's also selling the cases for $40. And the material that he's making this out of is very high quality material. You can. Yep. $40. Yep. So that's an option too. Yep, serial interface we don't officially have in our source yet. As long as you have a receiver on the other end of the serial that understands GDL90, then this is what we're using. We're using GDL90, which is the protocol to transfer traffic and weather. I've had a couple different people testing with different hardware. I haven't heard of testing with the Grand Rapids, but I think it's just I think they just got the traffic working yet, or
No,
it all works. So, so
Yeah, we modified it in software to do that.
So the testing we've done now is just a USB to serial device. I think that's what you're using there. So it's just a USB to serial dongle and plugs right in. Pretty simple software modification. Yep. That's a web interface here if you want to see it.
Yeah,
Yep.
with the single receiver.
Yep.
Are you going to get a new receiver? Are you going to get 1090 inside the hockey puck or not?
If you have ADSB out, you will get 1090 targets within the hockey puck. It's called
If you
ADSB.
don't, you won't.
If you don't, you won't unless you're in somebody else's hockey puck. Yeah. Say again? It does transmit on the same frequency. No, it doesn't. It's not aware of the identifier, especially for mode C, unless you're to say enter like your squawk code in there. And also mode C doesn't have any provisions for measuring distance other than from the radar tower because they're timing it. It's just a response. It's on the same seat frequency though. We don't display it because it's not useful information. It doesn't show anything really. It just shows response. I'll just show 1200. Okay, we received mode C 1200 and what altitude it's on. Mm-hmm. Oh, own chip, yeah. Yep.
Yeah, you put your airplane's ID in there and block it.
Yep, it's called. You can do that. There's we have this here. The do you have mode S? No. Yep. Yeah.
I guess if you can't identify that it's your airplane, then you can just block it out. Yep. I know there's an entry in there where you can put in your own airplane's ID stuff, but I think you're right. I think it would only work if you're sending in your out. Yep. So I have a question about the 1090 field. With the airplanes that are walking, sending out stuff that with no ADSB attached to it, could the receiver, does it give us a signal strength for every interrogation it picks up?
It does. This is actually a receiver that's outside and there's the power level.
So we were considering modifying the software a bit to send backdated shots, and then we could pick up both that information with the signal strength, and then we have other ones that are going to be signal strength and its position, so we know the range. We could kind of calibrate the signal strength to the range of the sun.
Signals.
Potentially provide like a Xenon kind of, we don't know which direction, but we can estimate a distance to it.
So you have signal strength and position from.
For some we do and some we don't, right? Because if it's got ADSB out, we use them both. But if we wanted ADSB out, still get the 1090. That was an idea I had. Because like right now, flying around here, we might low enough, you wouldn't get the ground station, but we could still, might pick up the interrogation. I don't know if that seems feasible or...
It is feasible. I think, like the other devices, the PCAT, I think they do the same thing.
Yeah. So that's...
The information's there.
Yeah.
Yep. So these are actual flights that are being picked up now. Yeah, so this is a flight box receiver, pre-built. It's showing a 3D GPS. You'll see a WAS signal if it says WAS. There it is. So there's the WAS.
Go through that real quick.
Sure. So this is the page here. This is the IP address. We're working on a way to make it easier, but you kind of have to write that down or bookmark it to be able to access this. Once you're connected to Stratux, you'll have all this information available to you. Version number, I'll show you in a minute that we now have an upgrade feature. This help, a lot of it is defined in the help. So it tells you when it's connected, the web interface. You can open this on your iPad and see all of it. Showing you status disconnected, or Yep. Yep. First thing, I would recommend upgrading. We had some issues with this connection here in earlier versions, so I'd upgrade it to the latest. This is not even the latest. I'd try that. Second thing would be refresh. And yes, you're right about you have to think about it. Right now we're getting none because it's on the ground, and you won't get UAT tower reception on the ground. Important thing to note. 1090, getting from those airliners. Zero towers, we're getting the GPS solutions, 3D GPS. That's having issues right now. Traffic. So this is just your what's being picked up when you're in the air and you're getting reception from a tower. You'll also have traffic targets that came from TISV, and they're a different color. Yep. So there's this in the settings here. It's meant for you want to have weather updates filtered. Enter in the identifiers here, and then weather will start showing here. So it'll just show you what is filtered here, the updates, and as you're receiving weather information, it'll scroll this list of what you're receiving in real time. Yep. So this is what is being discussed here. It's for detecting ownership, so that you're not, you get the traffic rebroadcast, but you're not showing the traffic alert for yourself. This, you need at least a Mode S transponder for this to actually be useful. It just sends the information to the iPad or tablet that you're using so that you can filter that traffic out. Yep. assigned based on the registration.
So if I put that in there, we can know about
You would ignore yours on the traffic, yeah. I think we're getting a bad signal now because the device is actually outside, but it's disconnected. Yeah. If we bring it inside, I think it would be okay. The GPS AHRS, it'll show you accuracy when it's actually connected. In towers, it'll show you the lat long power levels, average power levels, messages per minute per tower when you're in the air. So you don't get that again. Logs, that's just a few links there that will show you debugging information. If you're having an issue, it'll show up in the log. Okay, and so the new things here, in version 8, this is a beta version, but in version 8 you'll see the system update file, and now instead of, I don't know if anybody's been downloading the images constantly, but the 400 megs, this is very useful now. So you go to settings here, you click update system file, and you select the file, and then it'll upload it. You can't download it to your iPad because iPads have a limitation on how big the file is. It's only 7 megabytes, and there's no access to the file system. I'll show you what the update files look like. It's here. You go here to releases. They'll be linked on the website. This is SH file. You see it's 6.3 megs versus 300 and some. Download that, and it takes 5 minutes. Yeah, it also maintains all of your settings. Yeah, we can do that. I have this up here.
upside down though, I have a hard time, looking at the plans and visualizing stuff because in the right side up, left left and right, up and down.
That was a pattern maker. So blueprints, left and right, you got a left door and a right door, it didn't matter, you know.
Yeah.
I look at a complete dial, some of it I could see left or right, didn't matter.
Yeah, when things are upside down.
That didn't throw me. Blueprint wise, the RV was dog